Hey everyone, Derek Weeks here, and I am here with Justin Young to kick off the second session block of the day. We have Justin's coming up. We have John Morello from Twistlock coming up. We have Stefania Chaplin from London coming up in this section as well, and more speakers. So. We were just in Paris. We are now shifting to Los Angeles with Justin. Justin Young, as I mentioned in the last section, Justin is product owner of our integrations team. He's going to share a lot of what we've been talking about this morning, how you integrate our Nexus products with everything out there in your CI/CD pipeline, DevOps pipeline. We've seen how Fannie Mae has integrated a whole bunch of different things together in their pipeline, and what Mohammed just demoed live for us, which was super cool. Justin, without further ado, I'm going to let you take this away and show us what you have. So I can hear you. Let's get your slides up to make sure we can see them.
Sure. All right. Good morning from the West Coast. There's not enough coffee in the world right now. Right? All right. So from the source, I want to talk about integrations today. This is also going to be demo heavy. So let's get going. As Derek said, I'm Justin Young. I run the integrations group at Sonatype. I've been here for quite a long time, but about 2 years ago, I was asked to start the integrations team, and we've been doing it since then. Our goal has really been to try to push the utility of the Nexus platform out to the people who use it. The Nexus Repository Manager and Nexus IQ Server are, they're the workhorses. They're doing all the heavy lifting, and they're the brains behind the operations. But when users come to get value from Sonatype, it's generally through the integrations. It's through your CI/CD pipeline, through your IDEs, or even further left into your issue tracking systems. So today, I'd like to kind of talk about that vision and how I've seen it so far, how other people have seen it, and then we'll jump into a demo of what it looks like. So if I go to the right window, here we go. This is like the 30,000-foot view down onto what we do. It showed up on our corporate website. It's beautiful. It's 3D animation, and it would kind of make what Eric from the Phoenix Project happy. It's a well-running machine. It's a well-oiled factory. We got components that are coming from the left here in the brain, getting pushed through all the Sonatype tooling and then going out to the cloud. This does a good job of showing how we integrate, what we integrate with, but it doesn't really show our place in the pipeline. It's very Sonatype-centric, as you would expect. So here's kind of the product view. This is something we threw together when we were trying to figure out pipelines. It's more two-dimensional and probably equally as confusing. But you can see on the left, we have a Silicon Valley reference to a Pied Piper writing some code, pushing it to some source control, and then it gets put into this pipeline. And the pipeline has warehouses, and it has some leaves, and things go out to repository, things go out to IQ. They still end up in the cloud. But this is probably, as I said, equally as confusing to someone. It would make sense internally when we kind of distribute it and talk about it. But in a demo, it's kind of hard to describe what this is and what it's doing. So let's get to the demo. Let's talk about actually how a developer uses Nexus tools to deliver code. And as a caveat, I haven't actually made this all the way through without something crashing. So every good presentation needs some memes, and we'll see how we do. So let's get started. Now, the story I'm telling here is from a developer's point of view. I'm an engineer who's walking into the office on, let's say, Monday morning, considering how much coffee I'm drinking. And I have 2 work items on my Kanban board. These are going to be 2 things I'd like to talk about. One is the life cycle story. It's how life cycle can help you remediate vulnerabilities quickly, how it pushes things left. And the second is the component pipeline story. How to use Nexus Repository to deliver private components, to upgrade, to host your artifacts, to host your containers and images and push them out. So in true Kanban fashion, I'll start from the top. Most important, my product owner prioritized this for me, so I better get to it. This is an automated ticket that Nexus Lifecycles created for me in Jira. When Lifecycle notices new violations, you can set up notifications to push those violations or information about them to your Jira. This really streamlines the work process and the workflow, and it gets the information to your developers as quick as possible, or in this case, to me. Here I can see there's a new violation with Spring Core in 5.0.4 release, which I'm using. And typically, from my point of view, I would go to the report and take a look. Let's digest this for a second. So if I bring up the component history here, or timeline, I can see that there's a new version, 5.0.5, that seems to be vulnerable without any vulnerabilities. So this may be fairly easy. As a developer, put my smile on, happy about it. And I could just upgrade, but because I want to have a holistic understanding of what I'm doing here, I probably should also investigate what the vulnerability is. Why is it affecting me? So Sonatype provides this information. This is a vulnerability that was put into the National Vulnerability Database. And then we have some information straight from the CVE. The CVE here says that if I support multi-part requests to my server, and I, let's see, proxy them to another server, I could be exposed to an attack. Now, right away, I know I'm not doing this. So I could either make the fix or I could mark it non-applicable. But let's find out a little more. And you can see that there's additional value and information that Sonatype provides in this panel. Here we're pulling information from the pivotal disclosure that says not only do I have to be proxying these requests, the boundary value chosen by server A has to be known by the attacker. So they have to have access to my logs through a separate attack vector. So this is, although it has a high security CVSS score because of the result and what could be exploited, it really is not applicable to me and very difficult to exploit. Now that's a lot of caveats to say, let's still fix it, because in my mind and my recommendation to my manager and my product owner is that the fix is so easy that it outweighs overriding the vulnerability. So I'll jump over to my IDE, and I went straight to the report. My guess is, as a developer, I'd probably go to my IDE. I spend a lot of time nowadays as a product owner kind of looking at the materials in my applications and understanding how they're composed. As a developer, I'd probably just jump in here. It gives me the same details. I can get going. I can get working. So as promised, there's a version bump available, and it's 5.05. So fairly easily, I can do my remediation. I'm going to jump in here, and this may be the cheating way to do it, but let's just force the 5.0.5.release. Import my changes, and I'm going to rerun the evaluation in my IDE. This allows me to ensure that the changes work, that I didn't introduce any transitive dependencies that that I could be vulnerable to. And then also, I'm going to run Maven. When I do bump, it was a minor or a patch release, so it wasn't a big change to the library, but I could be breaking something that I'm working on. It is an API change at the end. It shouldn't be breaking, but there's something that changed in the library that I was consuming. On this side, we can see that we're all good. Evaluation is complete. There's 42, and there's not a single policy violation, so that's fantastic. Maven reports success. I should be good to go. So that was fairly easy to get done. I think that maybe it's a trivial example, and we can say that I picked it for the demo, because I did. But open source projects are really good at at hygiene, at keeping themselves up to date, at responding to CVEs, responding to vulnerabilities. The turnaround's usually quick, and there's often patch releases or other versions available without the vulnerability. So I think that while this is a contrived example that I put in, it could be a real world scenario. So a little stuttering here because Git is laggy on me. I'm trying to push this up to GitLab and had problems earlier. We'll see where we end up, and we may have to go back to slides. So everything's getting deployed here to a to Minikube that's running locally on my computer. And I have probably not given GitLab enough love. Seems to be rebooting for some reason. So we'll wait while it reboots, and I'm going to jump back into some slides and talk about some other things that the integrations team has done. Yeah, so the meme held true. All right, so pretty soon we're going to get over to Jenkins, and we're going to talk about automating pipelines. A big thing we focused on is being able to have configuration as code, so to have scripted and declarative pipeline support in Jenkins. This allows you to be sure that when you run the job, it's going to be the same every single time. When servers go down or need to be rebuilt, like we can see with GitLab right now, we need to, we get the same results time after time. This is really important. In a Kubernetes cluster, everything's pretty resilient. My 0.5 CPU I gave GitLab wasn't enough, so it went down, but it's coming back up, and it's going to have the same persistent volume. It's going to be able to recreate everything that I had there before. Having your configuration as code enables that. So what it also lets you do, and is it allows you to take the result of policy evaluations and let the robots do some work with it. So in scripted pipelines, you're able to assign a variable to the result. Here you have the evaluation results in the code, groovy code on the top. And what I can do with that is I can digest whether the lifecycle analysis is passed, what went wrong with it, and push it out to the tools of my choice. So on the bottom here, we see a screenshot from GitHub where the Nexus lifecycle analysis is passed. We talked earlier about developers being in the IDE and wanting to spending their time in the IDE, trying to digest information in the IDE. I want to be in the tool of my choice if I'm a developer. And often my source control, GitHub in this case, is the tool of my choice. This is where I'm doing my reviews. This is where I'm figuring out whether code is go or no go. And having the ability to understand what CI reports back to the IDE to your source control platform is very important. So not only do I know that the build passed, I know that Nexus lifecycle analysis is passed. I give it 2 thumbs up. Well, 1. I'm only allowed 1. And maybe the code gets merged to master. All right. So this looks good. Let's see if we can push. All right, we got our code up there. Now I am going to go back. Let's see. Actually, I'm going to go back to Jira here. And that got done even with a big hiccup in, I don't know, about 10 minutes. It was done so quickly I forgot to move my ticket into development. So I'm sure that my product owner is going to yell at me about that. So I won't make the same mistake with the second. Make Miramar service fly. This is my second work item for the day. The Maverick team, in case you didn't know, I went with a Top Gun theme for this demo. I don't know actually if I know that much about the movie, but you have to pick something. So Top Gun was it. The Maverick team just released a new util to make the Miramar service fly. Grab the latest library and make this thing fly. So I'm going to put this in progress as well. And I'm going to open up an XRM. All right, so here's my repository manager. And I know that the Maverick team has released something. I'm going to come over here and take a look at what's been deployed to my releases. So I have a couple of versions of the Maverick library. My versions include the date in them. This is just kind of how we do things on the integrations team. They allow you to push a lot of versions, a lot of patches throughout the day. We chose this because we wanted to get everything to production into our users' hands as quick as possible. And ordering by patching by version lets the CI determine determine the version and take that out of the human's hands. So I have a new version of this library. I'm going to include it. It's supposedly going to make my application fly. I think it was called Maverick Library. The version is here. And then lastly, the group was another Top Gun thing. All right. I have my local Maven settings pointed to this Nexus repository that I have running in my Kubernetes, my Minikube, as I have all my CI and everything. So you can see here that I included the new dependency, it got brought down, and we're good to go. So this was lacking a lot of documentation. So luckily, I know what I'm doing here, and this is about what the code I need to write. I went over to my friends over in Maverick, and I said, hey, yo, I got this ticket. It doesn't say anything. How do I make this fly? And they said, you know, we had this static library, the static util that we threw out there. That's how you do it. So I've done the change. I'm going to run Maven again, because in a real world, I'd have a bunch of tests. I thought about doing some tests in the demo. I didn't. I will be forever shamed for that. So I made the change. I'm going to commit this as well. And I'm going to push this out to master. I was able to use Nexus here to host my bits, to host my private libraries, to pull them in, to look up the version, to understand what the newest one is. And then also, we'll see pretty soon when we go through Jenkins, it's hosting the Docker images. So everything that you see running on my computer right now on Kubernetes was pulled through Nexus Repository. So if we jump over to the dashboard, you can see that I'm running my whole pipeline here. I have a GitLab Jenkins IQ repository manager. The Jenkins I'm using is a custom Jenkins I built. I threw Docker on it in order to communicate with the host and do all the builds. And if we go over in the repository manager and look at my Docker host hosted, you can see here it is. So this whole thing was bootstrapped with Nexus. I started up Kubernetes, I installed Nexus deployed Nexus onto Kubernetes, and then from there, I deployed everything else through Nexus Repository Manager. This allows me to understand what's getting thrown to my Kubernetes cluster. It allows me to have control over it. It also allows me to ensure uptime because I have all my images locally stored. This is very quick, right? The Kubernetes cluster itself has all the images it needs to run on it. So that's pretty cool. All right. So we made something fly. What have I not covered? What I didn't cover is what it looked like before it was fly. So let's take a little look at what we had going here. It's a Spring Boot app, as we probably should know from the vulnerability remediation we did. Hello world. This is very complex. And we made a change. So I would like to go over and look at Jenkins. All right, so Jenkins is going to open up here. We can see I have a service job and a deploy job, and I'm going to kick the service off. My policy violation is reported in here. I haven't run a build since I remediated that. So the hope here is that's going to go away. I just added the fly utility, so I should get that. Both these changes should be in this single build. And that's about it. In the perfect world, I probably should have let CI run in between each change, but we're doing this in a demo, and that's what we get. So I want to look at the pipeline for a second while this runs. If I can bring it up, I have it somewhere over here. All right, so if I can make this a little bigger. As promised, the Docker agent, the image that's building this is all being pulled from my private repository here. And I'm doing some Maven to build it. I'm running a policy evaluation. We talked previously that you can do policy evaluations in declarative and scripted pipelines. Here's we're in declarative, and we run it against Miramar service. Very recently, the IQ team has added some features to allow you to provision your Jenkins server such that the IQ application doesn't even have to exist. So if you have a bunch of new jobs that you're trying to build out, you can use Jenkins to provision the jobs on IQ server. I mean, that's really cool. Helps everyone get started really quickly. I released this. So this is really important. I'm pushing the jar here up to Nexus. So I have my Spring Boot app, it gets bundled all together, I build a jar, that goes up to the repository manager. And that's it, that's all I'm doing here. I have built my Java library, or sorry, my Java application. I pushed it up to Nexus, and then this particular job is done. I'm going to kick off the deploy. Now, if we jump over to the deploy, we can see, once again, using that private image, the deploy here is going to do a Docker build. It's going to do a policy evaluation on the Docker build. Now, why do I have two? I have one for my development, one for the jar itself, and then one for what's going into production. The production is my Docker image. It may have a little more than just what the application has, because it's going to have all the libraries that got brought in with the image itself. I'm using OpenJDK, so I'm going to have a lot of other libraries that get analyzed in my production build. At the end of the day, my production build is really what I want to use to do continuous monitoring and to understand what's living out on my production servers. And then finally, I push that Docker image back up to repository manager here. 31, yeah, and then that's it. That's my deploy. A little about the Docker file. I'm here pulling down my my jar from Nexus. So instead of letting Jenkins pass around all these artifacts and use Jenkins to do the handoff, I want to be sure that Nexus Repository has my my final version, my authoritative source of what this library is, or this application, sorry, again. So I pushed the application up to Nexus Repository, it's been released, and then I'm asking Docker, go out there and grab that down. Make sure that whatever is in Nexus Repository is the version that is running in production. So I pull it down, and then I run it. Let's see how this is going. We are stuck on our build. So strike 2 for the day. Generally, I will have to restart Jenkins, but we will see. No, looks like we're going, albeit very slow. But I can talk around it. And while this is working, what do we want to do? Let's go back and talk about other things that we've done. So native Docker scanning, we just talked about that. You want to be able to understand what the contents of your containers are when they are in production. So the Nexus lifecycle, the CLI, the Jenkins plugin, all the interaction points we have for lifecycle will now open up a image and scan its contents. And that allows you just a complete picture of what's running on your production systems. We have Docker Hub offerings. That's what you're seeing running right now. They got pulled into Minikube. We have offering on Red Hat Container Catalog for Nexus Repository Manager. So if you're a RHEL user and you want to get a RHEL version of Nexus Repository Manager, that's on Red Hat Container Catalog. That also is certified, which means that you get all the benefits that you usually get from Red Hat, fixes for any vulnerabilities on your operating system, any RPMs that need to be updated, they actually notify us immediately, and we rebuild that Docker image to reduce any vulnerabilities there. So that's pretty cool for Red Hat customers. We have some CloudFormation templates. We're in the DCOS universe. We have some chef cookbooks. So we've spent a little bit of time trying to give references and deployments to people who are using cloud platforms and would want to deploy Nexus Repository Manager or Nexus IQ Server. So also, in the last year, I think, Visual Studio. I've done everything here in Java and using IDEA, but we have a Visual Studio plugin. This is pretty awesome. If you're a NuGet developer, I actually started my career in .NET. I loved Visual Studio. I spent every single moment in there. It's really a kitchen sink of tools. So as a .NET developer, I spend a lot of time in Visual Studio. I need to have my policy evaluation there. If I'm choosing NuGet components, I want to make smart, informed choices using lifecycles information in my Visual Studio IDE. So very cool. You get NuGet packages, your bill of materials, everything else we've seen with the IDE extensions in Visual Studio. Last, I promised I'd be talking about our community. We spent some time trying to document things, making reference architectures, talking about APIs and seeing how they fit our needs and how they'll fit other people's. So we've been growing those out, and we have a growing community of people who are providing extensions and plugins and other integrations to the tools of their choice. We try to hit the most strategic integrations at Sonatype. We try to get ones that can truly enable all developers and their pipelines, but there's always going to be off cases where you use a particular tool or you have some process that's not the same as everyone else, or the bespoke solution for your organization. And we suggest that you open source those, because if you think that you're the only one out there, it's generally not true. Other people are doing what you do. Please open source them. Please talk to our community. We have Exchange at sonatype.com. We have a Gitter for the Sonatype Nexus community, GitHub. So get involved, donate, and share the wealth of knowledge out there. That's going to help everyone. So I have about 3 minutes. We're going to see if we got fly or not. It looks like we are still building. Such is life, but we got pretty far through the demo without crashing. So, I'm pretty happy about that. Spoilers are that the make fly was a little airplane ASCII character that would go around our hello world here. It was amazing. People would have clapped and the audience would have gone wild, but we missed that. So to wrap it up, let's see. All the code or scripts I have out today. Let's see, wrong slide. All the scripts I have to deploy all this to Kubernetes, to automate the deployment of the policies and the applications, and pretty much everything you saw is available on my GitHub account, Why Justin, Nexus User Conference Integrations. Very short README to hopefully get people started. This is hungry, as you can see, so I'll bump up the GitLab CPUs so we don't run into the same problem as we did at the very beginning of this, and I'll push that soon. And that's about it. I'll be available on Slack. I work here, so I'm not going to go anywhere. And that's what I got for you today.
Excellent. Thanks, Justin. Let me turn down the volume on the other thing so we don't get the echo. Justin, like everyone, you ran through a whole lot in a little bit of time, so we appreciate you. One, running through all that. Two, running the gauntlet of a live demo online, which always makes things exciting. The certified RHEL containers, chef cookbooks, Jenkins webhooks, Visual Studio integration, and more, as Justin talked about. I showed in the last segment how to get to our community integrations. You just go to sonatype.com. under the resources tab, there's community integrations there, so you can see what others have done. And as Justin said, we would love anyone out there to watching to contribute to the community integrations that we have. Justin's going to be live in Slack, as he said. There's a bunch of conversations going on there, so we'll look forward to seeing him there. And then I'm going to switch over now from Los Angeles to John Morello at Twistlock. John, where are you located today?
I live in New Orleans.
I can't hear you, so let's see. Bye, Justin. Thank you. Okay, let's see. Can I hear you, John?
Yeah, can you hear me now?
No, I can see you talking, but I can't hear you.
See, I'm not on mute.
So let's see. Probably go up to the gear up top, and maybe it's your. See if you can adjust your microphone there.
Yeah, is this any better? Can you hear me now?
Oh, so Nexus User Conference says it's just me. Hold on. Hey, how about that? Does that work?
Can you hear me now?
I can hear you now. Sorry.
Very good.
If it's not you, it's me, I guess. But that's why we have Slack, to allow other people to tell me how uncoordinated I am on the Hangout. So John Morello, CTO of Twistlock. Super happy to have you. I didn't catch where you were sitting today, so
in New Orleans.
New Orleans, another place. So we went from Paris to LA to New Orleans. Another place I would love to be, because I've been to the city so many times. Great experiences there. John, as I mentioned to you in Slack, I think ABN AMRO, Fannie Mae, Aetna, and perhaps others as well. It seems like Twistlock's logo is on every slide of every DevSecOps reference architecture out there, along with our Nexus products and Fortify and others out there in the community. So I know a lot of people out there are definitely interested in hearing what's going on at Twistlock, how you're working with your customers out there that are also working with Nexus. So without further ado, I want to just hand over to you. We'll get your slides up and running so we can make sure that we can see them shared and go from there.
All right, very good. Well, I appreciate the intro, and I'll go ahead and get right to the slides so we get them shared out.
Okay, I can see your slides.
Right. Are you able to see the full screen presentation now?
Yep, got it.
All right, very good. So again, I'm John Morello. I'm the CTO for Twistlock. A little bit of background on us, if you don't know us. We've been around for about actually a little bit more than 3 years now. We were kind of the first company that had a container security solution. Since then, we've really broadened our focus to really try to provide a security platform for cloud native computing in general. And what I mean by cloud native is all those things that are part of the cloud native computing foundation. So not just Docker and containers, but also OpenShift and Kubernetes and serverless functions, and as well as the virtual machines that we typically see people using as part of the overall application topology for even their containerized applications. What we see out there in the real world is less a kind of a religious approach to saying everything is in containers, to really being a more pragmatic approach and realizing that containers are great for a lot of capabilities. Serverless is great for some things. You still probably have some, I don't even say legacy apps, but some workloads that for whatever reason you prefer to run on a VM. And so we give you as a customer a full lifecycle set of capabilities that spans that entire environment. Obviously, talking here at this Nexus conference, I want to talk more specifically about what we do around the DevOps and CI/CD integration, the place where people use Twistlock and Nexus very frequently together to be able to secure that entire pipeline. But that's just one part of what we do, and I just want to make sure everybody understands the full scope of what's out there. So let's get into and talk about really what's different about securing containers. Obviously, containers are a different kind of mechanism for packaging and running applications. That's probably very obvious on the surface. However, the underlying challenges and not just challenges, but actually opportunities for securing containers are not always as obvious to people. So when you think about building a container security solution, not just one for the CI/CD part of the world, but also providing runtime defense and firewalling and all those things that are there are both advantages and disadvantages to containers, I guess, or let's say cloud native in general. And when I say advantages, I mean things that allow you to do security more effectively and more easily, and disadvantages for things that make those that make security potentially more challenging. So over the next couple slides, I'm going to explain what those advantages and disadvantages are, and then we'll talk about how we leverage the advantages to give you really a better, more secure CI/CD platform by integrating containers as part of that workflow. So containers have three characteristics that really make security, or give you at least the potential to do security in a different way than you've been able to do in the old world. Containers are minimal. Instead of creating a virtual machine that's got full-blown OS and data and libraries and the application code and so forth, which is really difficult to deterministically understand everything that's inside of that VMDK or virtual machine AMI that you have on AWS, for example. A container is much more minimalistic, right? The container includes your application components and the dependencies it has in terms of frameworks, but it doesn't include a full OS. It doesn't include data. It's a much smaller amount of bits, basically, that you have to deal with. If you think about a traditional virtual hard drive, it's probably at least 5-10 gigs maybe. If you think about a container, most containers that we see in the real world are tens, hundreds of megs. So literally an order of magnitude smaller. And the reason why that size is so important is it effectively allows software like Twistlock to be able to really completely and precisely understand all the components that are inside of those images in a much more reliable way than you can do with a full virtual machine. Containers are also very declarative. So a container is built from an image. An image is composed of layers. Layers are described in a Docker file. So in addition to being less stuff to deal with, that stuff is also by default better documented. You could create some kind of text format or something that would describe the way that you built a virtual hard drive, but that's an optional process, and of course, is not going to be something that you can rely on being present, in every environment you might go into. Whereas with containers, the only way to build a container is from an image. The only way to build an image is from this manifest. And so that allows, again, software like Twistlock to be able to go in there and really comprehensively understand what's inside of that image. We don't have to guess at it. We don't have to try to apply a whole bunch of different heuristics that that may have some fuzzy accuracy to them. We can be really complete and clear on what components are inside of a given image. And then finally, and this is more something that's really beneficial at runtime, but has ramifications upstream in that CI process, is that containers at least should be operated in a much more predictable fashion. Of course, you can, like with any tool, use it for good or for evil, and certainly there's some people out there that we've seen operate containers more like virtual machines and SSH into them and apt update and so forth, but that's certainly not the recommended or even the natural approach to use with it. That natural approach is to have something that's much more predictable. I deploy my container. That container has an image inside of it. When I want to update that image, I want to rev my software or update a dependency that it has, I destroy that container, reprovision a new one with a new version of that image that includes the new versions of the components. And so that allows you, from a runtime standpoint, to really understand what that image should be doing at runtime, and then look for anomalies relative to what is predicted to be able to identify those problems and prevent them without a whole bunch of manual rules having to be created to do so. So those characteristics, the minimalistic, declarative, and predictable nature of containers, those are the advantages. Those are the things that it enables from a security standpoint, enables you to do security more efficiently, more scalable, with less human operator involvement. The challenges that you have with containers, though, are also present, and these aren't necessarily flaws with containers. It's just different challenges because the technology itself is different. With containers, you typically are dealing with a lot more entities. If I had a application that I built, even a multi-tiered app that I was running just on classical VMs, like let's say a typical kind of 3-tiered app, even if I want to do that in an HA manner, I might just have a couple of VMs as the front end, a couple of VMs at the app tier, and then some kind of cluster database on the back end. If I want to really do that properly with containers, I have to decompose that into microservices. And instead of having effectively 3 different tiers and really just having replicas of each one of those tiers, I might end up having dozens, literally, of microservices there. I might have one microservice that's just for the initial logon page, a different microservice that enumerates products in this application, a different one for the shopping cart, a different one for managing your user profile, for example. The whole goal of doing things like this with microservices is to decompose that app and to make the individual components easier to build, to iterate, to scale, but that also means that there's a lot more things that you have to deal with and to secure. Furthermore, those things change a lot more frequently. Again, one of the benefits of this whole architectural model is I don't have to look at those tiers as monoliths. I don't have to say, like, because I need to make this small change to the way the shopping cart works, I have to redeploy this entire application that includes not just the shopping cart, but the user logon page, the user profile service, because all that's just kind of bundled up into one application. I can now make that change specifically to one of the microservices without changing the others. But that also means that the churn through the environment is a lot more frequent than what you may have been used to in the past. The third one is probably the most relevant one for the purposes of this talk today, which is that security becomes much more in the hands of the developer than it ever has been before. In the past, you could, as a developer, build your application. Hopefully you're using a tool like Nexus and scanning and understanding vulnerabilities and preventing those vulnerabilities before they're ever deployed, but not everybody uses tools like Nexus, of course. And then you would hand that application to the operator, and the operator would deploy it. And then you usually would have some kind of tooling, something like a Qualys or Tenable or something like that they would then use over time to look for vulnerabilities in that image, or in that application. And then when they found those vulnerabilities, oftentimes it would be the operator's job to say, hey, this VM that's running this application, it needs an update to the JDK or some other library that you're using. And the operator would be responsible for updating the actual application after it had been deployed. The developer would really just kind of worry about their own functional code, and the rest of it was up to the operations team to manage over time. One of the most fundamental differences with containers is because you are taking that entire application and shipping it as a kind of an immutable image, this thing that's not going to be changed once it's handed from developer to or into production, the developer now becomes responsible for updating that entire stack within their application. And that's a big change for a lot of organizations, because the same tooling that you've been using before in many cases will not be container aware, won't even be able to tell you where you have problems. And even if it does, it's not going to be able to help you address those problems unless it has integration upstream in that CI process. And the integration that Twistlock that we built with Sonatype within Nexus is a really good example of how that works. I'll show you guys some screenshots of that later, but basically the idea is every time you build your application, you are getting inside of that same build process data about the vulnerabilities that exist, the compliance posture of the image. Your security team can set policies that say, like, if this image includes vulnerabilities above a certain threshold, like high or critical, actually fail the build and force the developer to fix it before it ever leaves their environment. But this change, this responsibility for vulnerability management and compliance and configuration management being something that really only the developer can do effectively, is probably the biggest shift from a security standpoint as organizations move from more classical application management methodologies to something that's more oriented towards containers and microservices. So as I mentioned at Twistlock, we have a platform that does a lot of different things. The CI/CD part is what we're really going to focus on mostly, during this talk, obviously. But there's other things that we do that span that life cycle. So Docker has this notion they often talk about of build, ship, and run. And for those of you guys that are using Sonatype, or Sonatype products, you're probably more on the left-hand side of this. But as these phases kind of have blended together with this whole notion of DevOps and continuous deployment and so forth, a lot of people that may have historically thought of themselves really just as a developer are now being exposed to a lot more sort of operational aspects of the environment. So in addition to the vulnerability management and compliance pieces that are directly applicable upstream and in the entirety of the CI/CD flow, you may also have a need for things like firewalling and microsegmentation of the applications after they've been deployed, runtime defense, which is basically an active threat protection capability to look for anomalies within the application, again, based on that model that we can create because of the declarative and minimal nature of those images in the first place. And then access control, which is always an important thing for an enterprise. This is not about access control for your apps, but access control for the management plane. At Twistlock, we actually built the authorization framework that's in Docker itself. Red Hat uses that same thing in OpenShift. We also built the secrets management framework that's in Docker. So even if you're not a Twistlock customer today, if you're using containers and you're doing something around access control, you're actually using software that we built and contributed to the open source. So this slide is probably not terribly shocking, honestly, for you guys that are actually in this day to day and doing this as your profession. You probably have seen, hopefully not in your current job, but probably in some previous job that you were smart enough to leave, that a lot of organizations really don't have security integrated very much at all in the development process. Certainly that's not a universal truth. And we talk to a lot and have a lot of customers that really are very passionate about that and understand and see the value of again, shifting that security left and pushing it further upstream. However, even from what we see, that's more the exception than the rule. And in a lot of cases, development teams would be just as happy to not have any kind of security controls or requirements in place and kind of be left alone to develop and to ship their application however they would like to. But as I mentioned a few moments ago, as you adopt this cloud-native approach to building and running your applications, it is unavoidable. The only way that you can really secure those apps is to move more security knowledge, responsibility, and enforcement upstream in that life cycle versus dealing with it retroactively after the problem has already been deployed in production. So as you think about this and this 20% that are doing the right thing, it really is illustrating the fact that 80% of those customers, 80% of organizations really have some shifting to do. And this is not really as much of a technical shift. Again, tools like Nexus and Twistlock and so forth that you can use to help do that have been around for years now. It's really more of a people and process shift to understand that there is a change to the way that you have to build the software, the responsibilities of the different teams involved, and then to adopt that notion and those changes into your day-to-day operations. So what do those changes actually look like? What does it mean for you as a developer when you think about vulnerability management and compliance and so forth in your day-to-day job? So there's some key differences between the old world and the new world for vulnerability management. As I alluded to earlier, the traditional model, the vulnerability management was often done as a post-deployment job. Somebody built their application, and even in a high-functioning sort of development environment, they build their app and they would run some kind of security scanning tool on it afterwards and then go back and remediate vulnerabilities. In a lot of cases, that didn't happen, and only after the app was deployed would the operations team use some kind of scanner and find vulnerabilities, and then somebody would have to go back and remediate those problems. However, even in a case like that where it was a fairly high-functioning team, you didn't have the ability to say that every time that you build and every time that you deploy, that deployment job or that build job has to meet this minimum threshold to be allowed to complete. And that's one of the things that the modern world allows you to do. So you can have that vulnerability scanning integrated into Jenkins or Circle CI or TeamCity or whatever tooling you want. We have native plugins for all of them. And obviously we are able to share that data with Nexus through the integration that we have. And that really allows you to have that scanning and that experience in a much more natural way for a developer. As you guys probably are all familiar with in your personal lives, if you have to build something and then step out of your normal build environment and dev environment into a completely different tool to scan it, and then you get results in a different format, and you have to go back and figure out how to reconcile that, it really adds a lot of friction, and friction ends up, frustrating people and getting them just to kind of ignore it. And so we've really prioritized this notion of making it a integrated, natural part of the experience, such that every time you do a build job, you get that vulnerability data back in the same UI that you're already using for building your application. It's provided to you in a really rich format, so you don't just get something that says like, hey, package foo version 3 has a vulnerability. We give you all the rich data about it. It's this version, here's the description, here's a CVSS score, is it remotely exploitable or not, does an exploit exist in the wild or not, is the vendor fix available yet or not. So you can be very smart about what do you focus on, because one of the challenges that you often find with this is, even in a fairly small environment, you might have, hundreds of images, thousands of total vulnerabilities. If you don't have the intelligence built in to help you focus on the things that really matter, you get lost in the noise and are really never going to be able to address those things that are most important. And so providing that visibility, that integrated awareness is really key. Automated and policy-driven blocking of builds and deployments is another key aspect of this, which is to say, in addition to being able to integrate into that dev process and show the developers, here are the problems, here are the vulnerabilities, to actually be able to set in place a process and a flow there that says, if the vulnerabilities exceed what's allowed by policy, actually prevent this build from succeeding. Actually fail it, force the developer to fix it right then and there when it's the lowest cost, the least amount of effort, before it ever exposes you to risk in production. At the same time, though, we also have capabilities that say every time that image or any image is run in production, we're going to assess the vulnerability posture of that image at that specific point in time and only allow things that pass policy then to be deployed. So if you build your image today, maybe it's totally fine. Over the weekend, there's some critical CVE that comes out. On Monday, you don't want to deploy that image into your production internet-facing cluster if it's got a remote code exploit for something that's in critical nature in your application. And because we're providing kind of that dual-step process, not just at build time, but also at deploy time, you have multiple layers of defense and depth there to make sure that you're only deploying things that meet the posture that you've specified for your environment. And of course, that's completely granular and configurable. So you may have different rules for dev and test and prod and the US versus Europe and so forth. But the end goal with all this is to allow you to express that policy one time and then to have the security platform enforce that all the way upstream and all the way downstream. Compliance is kind of the next area that we talk about. When I say compliance, what I'm really specifically talking about is kind of the security configuration of your application. So think about, best practices like not running stuff as root, not embedding private keys in your image, not having SSH embedded within your image. We contributed to the Docker and the Kubernetes CIS benchmarks. We actually wrote the NIST special publication, or I should say we're one of the primary authors of NIST SP 80190, which is the Container Security Guide. So we've been really involved in trying to help the industry overall set policy and best practices around secure configuration for containers. And so what we've done in our product is we've taken all those several hundred checks and put them in as just pre-built individual checks that you can build your own template for enforcing. You can also use pre-built templates we have for things like PCI, HIPAA, and GDPR, where we've gone and pre-selected which of those individual checks makes sense to support one of those standards. And again, the traditional approach to doing this would be, if your dev team was even aware of these things in the first place, they would have to manually check that as part of the build process. There's very few tools that really do that in a generic way because, again, without containers, you don't have a consistent packaging and image format such that you can have software that really looks at all the different kind of application frameworks and artifacts you might create to find these best practices. And so then what often would happen was you would build your application development with certain expectations. It ran maybe as root or whatever settings you had in development. You'd hand that app over to the guys that were going to run it in production, and suddenly the app would quote unquote break, right? Because it required to run as root, or it required that it was going to have like this private key at a particular path, or whatever it may be, that was different between development and production. And one of the things that we can do now with having this consistent format of a container image is we can again apply those same compliance checks upstream in the development process, such that every time you're doing a build, we're going to enforce that that build is compliant with whatever policies you have in place in production. So it's a full fidelity of configuration settings between the build that you have in your dev environment, what you test, and what you actually deploy. So there's no ambiguity or confusion about what the settings should be. And again, you have that multi-level enforcement at the CI process at build time, in production at deployment time, to only allow those things that are compliant with your policies to actually be deployed. And then because you've got this pipeline that everything has to go through, we can also provide this really rich dashboard, something we call Compliance Explorer, that shows you all the checks specific to your environment that you've enabled. It shows you the real-time status of all of them. You know, you're 80% compliant or 40% compliant or whatever with this check, what the outliers are, so that instead of you guys having to do compliance the old way, which was, you know, you gave some auditor a couple of sample systems and they ran some tools and they put it in Excel and the whole thing was super painful and took like 3 weeks. Now it's just part of the build job and you can automate it. It's all software. It's something you can see, that you can understand, and that you can enforce, again, through a centralized policy. One of the things that we focus on in the product as well, and really our whole relationship with Sonatype, has been about having a really great developer experience. And so one of the things that we've tried to do is to ensure that as you build your images as a developer, you get really useful, clear information to be able to understand where vulnerabilities and compliance defects exist within that image. Because what we see, especially within large organizations, is oftentimes images are built by multiple teams or multiple individuals on a team, right? You might have 2 or 3 developers that work on the same thing and each kind of work in their own piece of the application. And so one of the things that we do, and you can see on this screenshot here, is we actually take the image itself, and for every image, we show you the vulnerabilities that are associated on a layer-by-layer basis. So as you scroll through the layers on the left-hand side, the actual Docker file that composes that image in that right-hand pane is constantly being updated. The line that you're on will be highlighted. You can see what layers have added what vulnerabilities. So when there are CVEs that are detected in a given image, you can go to exactly the right layer in the image to be able to fix it and know exactly what developer needs to do so. All of the image results that we have are all correlated around the image ID, the digest value, the SHA of the image itself, which means that it gives you a really powerful way to tie together that immutable nature of container images from development to production. So when you're doing those scans in the very beginning of your development process, and you can see that, you know, an image with the SHA value of 123 has these versions of these components and these CVEs, that data doesn't just exist inside of your build job. It's shared with our central console, which is kind of environment-wide, which protects your upstream work as well as your downstream production environments. And as soon as that image is introduced anywhere else in the environment, be it in another build job, be it in production, we don't have to go and scan that image again to know what its posture is, because we already know the posture of that image as uniquely identified by its SHA, and anything that would have changed any aspect of that image will invalidate the SHA. And thus we have this model that allows us to basically say, no matter where this image is seen over time, we definitively know all the components, all the versions, and then can then detect vulnerabilities across that environment without having to scan the images again. Because in our console database, we know that, again, this image includes these packages with these versions. So when a vulnerability comes out and we ingest that through our intelligence stream, and then your console that you run in your environment pulls that data down from our intelligence stream, you can instantly identify all the full scope of vulnerabilities across your entire environment. And one of the places where that's really cool and useful is this capability that we have called the risk tree, which helps you analyze the exposure that you have to vulnerabilities across your environment. So instead of you having to, as again you had to do in the old world, to really kind of say, if this new CVE, like for Heartbleed, for example, comes out, I have to go kind of manually figure out what components are vulnerable. I have to then go and look at like what VMs are running those components. And, it's a lot of work and a lot of kind of Excel drudgery where you're putting data from multiple systems and trying to munge it together. Again, the nature of containers enables a tool like Twistlock to say, we know that this CVE impacts this version or these versions of this component. We know this component exists in these images, that these images run in these containers, that these containers run on these hosts, and that these hosts exist in these clouds. And this risk tree that we have is literally an API, as is everything else in our product. It's literally an API and a UI where you just say, like, here's a set of CVEs, show me, basically build out this hierarchical view of all the places that I'm exposed. And then you can instantly understand what images need to be updated and go back upstream in that development process, fix those images, redeploy them, and take a huge amount of effort out of that, detection, understanding, remediation work stream that you're constantly having to cycle through as new CVEs come out. So this is a really clear example of how those characteristics of containers really enable a better security posture over time. As I mentioned, we've done a lot of work literally for years now for integration with Nexus IQ. Certainly, we'd be happy to talk with anybody that wants to know more about how we integrate with upstream tools like Nexus. And you can see that commonality of data between the really far upstream artifacts that Twistlock is not looking into at all. The things that might exist like just in a file share, a jar file that sits on some server someplace, to the images that we do look at as part of the build process, and how you can see that data together with Twistlock and Nexus. And then the things that we do downstream that are unique in our product, like being able to scan images that exist in your registry and all the runtime and preventative things that we can do post-registry at production, at deployment time. So it's really a better together story where when you have a tool like Nexus and Twistlock together, you really get full spectrum vulnerability from the very earliest phases of the build process all the way through production runtime across any cloud, wherever you're running those applications. So just to close, I mentioned we have a lot of other capabilities in the platform around active threat protection. I'm not going to go into these in a lot of details. Certainly, we'd be happy to talk with anybody and show them to you. If you want to visit us at twistlock.com, you can see some details for that. We have a really neat tool that we call Runtime Radar that gives you this basically live Visio of all of your microservices and how they talk to each other. And we overlay all that information with vulnerability and compliance posture for your images. So it really, again, ties together that notion of what you've deployed with what we know about upstream as part of that CI/CD process. So with that, I'll go ahead and wrap up, and certainly appreciate you guys listening in, and be happy to take any questions.
Hey, John, thank you so much for going through that. Yeah. Mute my other system over there. It's as you said early in your presentation, there's more security in the hands of developers now, and making it easier for them with tools like this, where security is being embedded early and throughout the development lifecycle. So it's great to see some of that work. As I said, it seems like everybody that's presented on here is using Nexus and Twistlock together within their environments. It seems like kind of a standard pattern to see within environments. So we will catch you in the Slack channel for Q&A. And if you could, when you go in there, share your slides so that anyone that wants to get a hold of them can do that as well.
Absolutely. I'd be happy to do so. Thanks for having us. I really appreciate it. Enjoy talking with everybody today.
Yeah, thanks again, John. Really appreciate it.
Okay.
Bye. Okay, now Stefania, let me get Stefania Chaplin in. So Stefania, we can see you in the broadcast again. We can see you live. Are you in our London office today, or are you somewhere else?
I am in one of the London offices. So I was at an event today, so I got an Uber to a localer one. So
we are all on the road somewhere. So we've We've been in Paris, LA, New Orleans, Washington, D.C., and now London this morning. So Stefania is on our sales engineering team in Europe. She's been speaking at a ton of events lately. So you were just at an Atlassian user meetup. Was it yesterday or 2 days ago?
It was last night in Germany.
Yeah, of course. Of course you were in Germany yesterday. So welcome, jet lagged to even though it's only an hour's difference, back to London. You're going to do some 5 lightning solutions with the Nexus platform for us. So Stefania has been great in posting some of her work on online on videos and demos that she's done. So looking forward to this session. I know we ran a little late on the last one, so I'm just going to hand it over to you. You want to share your desktop, and so we can make sure that we can see that. Yep, I can see your slides.
Perfect.
I'm going to go off here, and we got your full slide view. So you're ready to go.
Ready to go. Thank you for that introduction, Derek. So I'm Stefania Chaplin. I'm a solutions engineer for Europe, Middle East, and Africa. So I cross loads of different industries, different size companies, different countries, different languages. So I get to see a lot of Nexus in action. And I'm going to be presenting 5 lightning solutions on the Nexus platform. And you can also find me on Twitter at DevStepOps. So in terms of my presentation, it's quite short. There's just one slide because my presentation is going to be about 95% live demo. So fingers crossed. First, I'm going to look at using Docker in the Nexus repository, both proxy and hosted. Then I'm going to do the number 2 and 3 kind of in tandem. So first, I'm going to use the UI upload in the Nexus repository and then demonstrate staging within the repository as well. And then I go on to using Ruby within our Nexus firewall product for both audit and quarantine. And finally, I'm going to look at a JavaScript bill of materials in the Nexus lifecycle. So first, let's start off with number 1. So Docker. Oops. So here I am in my Nexus repository. With the repository 3, some of the big differences that we came about were increasing language supports. You can see here Bower, JavaScript, Ruby, Node, etc. So for Docker, first what I'm going to do is I'm going to show you what it looks like to set up a repository. So I have a couple already. So you can see Docker proxy, internal, and all. It's very easy to set up. I just press create, and then I select the type of repository I want. For example, Docker proxy, I need to put in my remote storage, etc. So going back, I'm going to show you his 3 I made earlier. So if I look at Docker proxy, it's very simple. I set up my HTTPS. I want to say the kind of registry I'm going to, and just click save. Similarly, for internal, that's for my hosted 18082. The reason I'm mentioning these numbers now is they're going to be slightly relevant when I come to my demo. So I select that, tick some boxes, and press save. And then with the final one, Docker all. So this is my group, so 18075. And you can see it's for both my internal and my proxy. So now jumping into the live demo. So I've got a little Docker tab ready for demo. So first, just to show you my system is empty, Docker images empty. Oh, I forgot to show you one thing. In my actual repositories, we looked at the setup, but actually if you look inside, Docker proxy is empty and Docker internal is empty. So jumping back here. So what I'm going to do first is I'm going to log in to my Docker proxy repository. So here is a command I made earlier. So this is my unique IP address. And then this is my group repository. So I'm going to log in with my top secret credentials. And here I am logged in. So next, I'm going to pull an image from that repository. So pull, and then /docker/whale set. So it's getting the latest tag. You can see I've already got some of the layers here, and then it's downloaded the latest image. So when I go back to my Docker proxy, all of a sudden you can see it's populated with my whales A. So what happens if I want to push in my local repository? So first I'm going to show you, I should have, all fingers crossed, you can see here's the whales A I just downloaded. So what I'm going to do is, if I get this command, I am going to tag this. So I'm going to tag, I'm going to select the image ID, and then I am going to change the port number, which is why I said it's important to look at the 7582. And I'm going to name it Stefania tag. So then I've just tagged this image. So the next thing I need to do is I need to log in. So in order to log in, I need to log into specifically that port. Oops. I need to do that without the image ID, of course. That was my mistake. Yet again, using my top secret credentials. And login has succeeded. So next, I'm going to push that tagged image. So get rid of the image ID, as I forgot to last time. And I am going to push. And you can see here, it's going through pushing this. And fingers crossed, this will show up in my Docker internal repository. So pushed and all done. So if I go back here, go to my Docker internal, and you can see yet again, my Docker whales A has been pushed to the repository manager. So obviously this has been, quite a, simple example. I've just been pushing and pulling, but obviously, if you're doing, containerization, it can be very, very valuable to do this within the Nexus Repository Manager. So next, I'm going to go to showing using the UI upload in Nexus Repository. So it's very easy to use. As you can see on the right-hand side, I have a simple upload. So I'm going to be showcasing staging at the same time. And to do staging, I've got 3 example repositories, but I'm going to talk about them in just 1 second. Initially, I'm going to go to staging development. So I'm going to add a file. You can see here I've got my web container. It's a war. So bear with me. Oops. If I can type. org.webgoat, webgoat container, and then 7.0.1 upload. So this is a very easy way to upload into the system, whether you're uploading WAR files, jar files, or other components that aren't necessarily in the Java ecosystem. This functionality recently came out with 3.9. It's a very easy to use user interface for uploading the component. So that was number 2. Next, staging. So this kind of carries on from upload, because as you can see, I went into staging development. So staging enables the movement from components from one repository to the other, because what you may find is your developers will upload to staging dev, and then you might want to have your testers go in to test the application to see if it's vulnerable for anything, or just do testing in general. And then finally, when they're done with testing, then you might want to push it into a production repository. So you can see here at the bottom, I've got staging dev, staging test, and staging prod. When I go into browse, just to show you, well, they're not all empty because staging dev, I have just got my webgoat container, so you can see here. Staging test, that is empty. And then staging prod is also empty. So the way that we demonstrate staging at the moment is through API calls. So if you go into the system configuration, you see API. So we have a really rich, and easy to use REST API calls. So for example, you might have get tags. At the moment, let's try it out. I should not have any tags. And when I go into, put this in a new browser, I don't have any because I haven't set up my tags yet, but this is an example of how you could show them, and then you can do different things with them as well. So now on to my staging demo. I've set this up via Jenkins. This is for ease of use so that I have the kind of commands preset and I can run them. I'm going to show you the commands that I will be running as well, and also, you know, how we can do it slightly differently if we have extra time. So my first job, I'm going to create a tag and associate the tag to the development repository. So that will associate with the web code we just had. Need to log in, obviously. And if I go to configure, at the moment, I'm just using my build job. I'm just using it as a shell step. So you can see here, I'm doing a curl command, going into my repository with the tags, and I'm adding this metadata. So another real benefit about staging is you can now add custom metadata to these tags. So for example, this tag is called webcode. It has a build number, a commit ID, and a build URL. So that could be the build report. If I had more time, I would obviously set up a Jenkins job to create a build and scan at time. But for now, I've hard-coded it, but it is possible to do it in the system. My second shell step, so what I'm doing here, it's just the end bit that is important. I'm associating the webgoat tag with the repository staging dev. So just so you know what's happening, I'm going to build now. And if I go to my output, so you can see here, I've created a tab webcode. It's also got the build URL. If I click on it, for example, it even goes straight to my report. So, you know, how great is that? If I go back to Jenkins, whoops, you can see the next step, it's doing an association. So it's associating the webgoats with this tag. If I go back to, this was my URL for testing what tags I have in the system. You can now see I have a tag called webgoat and, you know, with it the enriched metadata. Just to be triple safe, I will show you as well in my repository. My staging dev is the web container is still there. If I go back to my project, back to dashboard, so what I'm going to do is move from the development repository to the test repository. This is just one shell step. And similarly, you can see move staging test tag webgoat. So let's go back into our, cool, let's build that. And if we go to the console output, you can see move successful and it's gone to staging test. So to show that, here I am in staging dev, refresh, and you can see it's gone. But when I go into my staging test, here I have my webgoat container. Next, I'm going to go back to the dashboard and I've got move from test repository to production repository. And you've guessed it, I've got move, staging, production, tag, webgoat. So it's just a very simple, easy to use curl commands. And when I build it, you can see here, move successful to staging prod. If I go here similarly, now it will no longer be in staging test. However, when I go to staging prod, here I have my webgoat container. So this is awesome. But what happens, maybe there's a problem with this specific build and I'm like, okay, this can't go to production. I need to erase what I have so far. So if I go back to project, I've set up a fourth job, delete tag. If I look at the configurations, what I have here, staging, delete, tag equals webgoat. So obviously be very careful when you use these steps because it does do exactly what it says on the tin. If I go here, go to my console output, components, deleted, webgoat container, delete successful. And similarly, when I now refresh here, it will be gone. So that's how you use staging in the Nexus repository. Not finally. Next, I'm going to go on to Ruby Firewall. So the way that we configure Firewall is a couple of easy steps. So if you go, first you have to go to IQ server, and here I have my IQ server linked. Then we add a capability. So I've actually got mine set up already. But if I go to settings, you need to do 3 things. Enable this capability. Select which repositories. You can see I've got a couple. And then enable quarantine, because firewall has 2 aspects, audit and quarantine. So what quarantine means is if you're trying to download a component for the first time and it violates a policy, say it has a really high CVSS, what this means is it will stop at that point and will act as a form of ingress control. So let's check it out. If I go to my second tab, Ruby Firewall, I'm going to download a component called Gem Install Yard version 0.9.1, because I know this one is actually vulnerable. When I try, what happens? There's an error while executing. Requested item is quarantined. So that's not great. Let's see what that looks like. If I go back into my repository, you can see here my Ruby gem proxy, and we have this kind of quarantine symbol here. So if I click on it, I need to just log in. And what we have here is a repository bill of materials. So here I have every single Ruby gem that I've ever tried to download, and you can see most of them have no violations, but there are also some with some serious problems. And you can even see one quarantined component. When I go to quarantined, I can click in here and I can get even more information. So I can see, the coordinates, so name, platform, and version, information around licensing, and also around these kind of security threats as well. I can also use this slider, so I'm on 0.9.1. If I go to, say, 0.9.4, all of a sudden my security threats and policy threats disappear. So this is great. This is the version that I want to use, so I could then make a request for yard 0.9.14. On this version, there are 2 security issues. So that's where Sonatype really add value, because we have a team of 65 data researchers taking a total of 78 feeds. And for each component, we'll add enriched metadata. So you can see, for example, if we have a look here, we give you an explanation. So we're saying the jQuery package is valuable to cross-site scripting. We'll give you detection guidelines, so the application is vulnerable by using this component, and also a recommendation. So in this instance, we recommend upgrading to a version of this component that is not vulnerable. So in this example, it would be 0.9.14. We'll always show our working as well. So what if I decide that 0.9.1, hey, I want to let it in, it's okay. So you can see here the policies it's violated and proxy failed. That's the firewall product. Maybe I want to wave. So I'm like, okay, I'm going to let it in this repository, this component. So once I wave, I can also release the quarantine. So what that means is it will then go, you can see 0 quarantined components, and then it will be back inside my repository. So my developers will be able to use this. I can show this by trying to download it again. Okay, so I've got permission denied. I think that's a logging in issue. So this has been Ruby Firewall Audit and Quarantine. So finally, I'm going to show you a JavaScript bill of materials in Nexus Lifecycle. So if I go into organizations and policy, I'm going to look at my JavaScript team, and I have OWASP Juice Shop. So I'm going to pray the internet is on my side. What I've done, OWASP Juice Shop is an intentionally vulnerable JavaScript application. I've downloaded it, I've taken the node modules, and I've turned them into a zip file. And what I'm going to do is I'm uploading it to the system. So this is functionality within Lifecycle. So you can either integrate within the IDE or within the CI tool or in the CD. What I'm doing in this example is I've just uploaded the zip file, or you could upload a wall for Java, for example. What it's doing is it's taking cryptographic hashes of the binary dependencies. It's then matching those hashes with our Sonatype data services, and then it's returning the enriched metadata and evaluating against the policies that your company sets. For example, you can see a couple of them below to do with licensing, security, or architecture. So with JavaScript, as it is a very, rich ecosystem, there are a lot of components. I believe this report has, I think over 8,000. So that's why it's taking, a little bit long. But actually, if you think of this in the scheme of things, it's actually incredibly quick because all it is doing is matching against the cryptographic hashes of the binary dependencies. So hopefully this report should be here any second. So I'll play some elevator music whilst I wait. Okay, maybe it's this internet connection. What exactly is happening in terms of with JavaScript is the way that we check our JavaScript is to do with, I'm not sure if you guys have ever used, or guys or gals have ever used jQuery, but it is a very, there are over 72,000 versions of jQuery. So how are you supposed to know, what version that you are using with that many out there? So what we do with our cryptographic hash-based matching is we try to give you as much information as possible. You can see here we're kind of evaluating the policy. So I'm just going to try and close this. I'm going to look at a report that I made earlier. So you can see here, if I go to my report and it's loading. So that's why it was taking a little long and I got impatient. It's analyzing nearly 9,000 components. And you can see that there are a lot of security alerts and licensing. When I go into policy violations, you can even see, for example, the file name it's in, as I mentioned about jQuery. Oops. You can see there are many, many different versions of files. What's quite interesting is actually there was an error that we found with this component, sanitize HTML. And this is why I mentioned our data team before, because if you go to the vulnerabilities, yet again, it is a cross-site scripting, but the only source of this data is within GitHub. And if I go here, you can see exactly where this person who owns this project referenced this OWASP attack. It's nowhere else to be found. You can also get information, for example, around policy, licenses, policies, or looking at the component info. And yet again, I can see if I go on 1.52, you can see that that would be, for example, a good version to use. If I have a look here, for example, I think it's one of these. You can also look at the occurrences. You can see here node modules, node modules, node modules. With JavaScript, we do find there are a lot of transitive dependencies. So we are able to map that down because, for example, as you can see, this is a transitive dependency, but it has a CVSS of 9, and it is a vulnerable component. So we've had a look just now at using Docker, using the UI upload and staging, looking at Ruby and JavaScript. So I want to thank you all for listening. I'm going to be on Slack if you want to continue the discussion. And you can also find me on Twitter at DevStevOps. So thanks for listening.
Stefania, that was great. Thank you so much. Amazing to run through 5 quick demos online, even with the internet not fully cooperating all the time. So yeah, definitely appreciate what everyone has tried live with demo.
Yeah, actually in the office, my lights switched off halfway through the demo, but I was like, it's fine. I'm just gonna roll with this. I can demo, so I'm slightly darker now.
She's demoing in the dark, folks.
Demoing in the dark.
So some great, we'll definitely take the session here and we can split it up into individual demos that you did. So the staging demo was very cool to see how you move from dev test to prod using that and how simple it was. The Ruby firewall demo was definitely very cool and easy to see, quick to understand. Unfortunately, the internet connection didn't didn't cooperate as well in the JavaScript bill of materials. But it was cool to see that anyway, and just kind of see the insides of the product. Stefania, do you want to talk? It looks like we have a minute before the next session starts. Women at Sonatype and the stuff that you're doing there. You're speaking at the Silicon Roundabout.
Yeah. So I'm really excited about that because I know in America you have Silicon Valley. So in London, we call it Silicon Roundabout, which is the area near the city. It's Old Street. It's a roundabout. So I'm going to be talking about DevSecOps at that event. And for me personally, it's a really passionate area for me. Women at Sonatype. I think I remember talking with you in January when I was starting to found it, and now talking at events about it and using it as a recruitment push. Being in touch with marketing. So, I'm always really looking to meet, women. I'm actually going to be talking at a meetup, Women in DevOps in London. So, if there are any women out there listening, please get in touch because I'd love to hear from you.
Awesome. Thank you so much. And we appreciate all your work that you're doing there and how visible you are for Sonatype all over Europe. So thanks again for your work. We'll see you in the Slack channel where you can share more insights on what you're doing. And next we have Curtis and Siamak online to talk about Red Hat OpenShift environments with CI/CD pipeline. So Stefania, we'll see you in Slack.
Cool. Thank you.
Bye. Okay. Siamak and Curtis, you're now into the broadcast. We will get you unmuted here. Curtis, I see you're at home today and not on the road.
Yeah. Rare stint at home.
I know. What's it like?
Hi, Derek.
Hi, Siamak. How are you? Where are you located today?
In Sweden. I'm always in Sweden. At home, though.
Of course. So we go from London, Sweden. Curtis, you're in Connecticut, or
Connecticut? Yeah. So we're going to push the internet to its limits here.
That's right. So I'm super happy to have you guys on. So you're going to show us. Curtis has been working a lot with Red Hat and the environment there in the OpenShift environments, our integration there. So you guys are going to talk about a CI/CD pipeline within OpenShift. And are you doing live demos or slides?
No, live demo.
Live demo, man. This is live.
Anything can happen, folks.
Live demo day. So we'll see if the internet cooperates for you guys. So who do I pin on the demo, or do I pin either one of you as you're jointly presenting?
We're going to start with Siamak, and then we'll pass the screen to me midway, just to add complexity to an otherwise already dangerous.
You're gonna make sure I pay attention. Okay, Siamak, you have the screen. So.
All right, let me share my screen.
Okay.
Let me know if you can see the screen.
I can see the screen. I can see your slides.
Okay, super. Maybe I start with saying a word about myself. I'm Siamak Sadeghianfar, DevOps evangelist at Red Hat, working mainly with a product called OpenShift around containers, Kubernetes, CI/CD, a lot of app dev. And I have Curtis with me. Curtis, do you want to introduce yourself?
Yeah, thanks, Siamak. Also an evangelist, but I do a lot of our strategic alliances and technology alliances and stuff here. So that's why my involvement with Red Hat. You can also find me at on commit. That's my sort of professional handle. Yanko is my personal Twitter handle. I try to keep the two separate.
All right, so we have quite a lot of stuff prepared for you to show you, and what we want to talk about mainly is how CI/CD looks like in the age of containers, especially with security in mind. So containers are quite popular now. They have changed how people package and deliver software, and for good reason, because it makes them a lot more productive instead of deploying things on virtual machines. And Kubernetes has become the de facto standard for orchestrating these containers on top of different type of infrastructure. So what we want to show you today is how would that look like in practice. As an example of if somebody's building application, Java application with Spring Boot, that's also quite popular these days, especially if you're building microservices, to take that application, deploy it in different environments, make a change to that, and more importantly, when we were deploying in the age of virtual machines, our guidelines and principles for how to deal with security was very well documented, well understood. Fast forwarding to the containers, that somehow was left behind. Security didn't come along, so people started building a lot of containers. And since there were no guidelines or practices in place, we sometimes run into issue of people pushing things that have maybe security vulnerabilities into production. So we want to talk a little bit more about that aspect of delivering applications as containers as well. I'm going to start with very briefly talk about what OpenShift is. OpenShift is an enterprise Kubernetes from Red Hat. It's certified Kubernetes, and it adds a little bit stuff underneath to simplify operations of Kubernetes. Installing Kubernetes is fairly simple, but when you get to upgrading to the next version, patching it, managing different operational aspects around that, it becomes very difficult to run Kubernetes for a long time. And with OpenShift, we try to address the operational aspect of running Kubernetes on one side, and the other side is adding some application lifecycle management around it for developer to make it easy for developers to use Kubernetes for building and deploying applications. We're going to see some of that as well today. It's Kubernetes, so it can run on any infrastructure, of course. What we're going to look at today is the Kubernetes instance, OpenShift instance that is running on Amazon, and you can deploy any application on top of that. Today, we're going to use a Spring Boot application. Curtis, you want to walk us through what products from Nexus we're going to use in this demo?
Yeah, can you advance the slide? Am I not seeing it? Oh, there we go. So, right. So, of course, we're going to feature Nexus Lifecycle because we're in a CI/CD setting. What's going to be a little different here is we're going to have an opportunity to actually go through the remediation workflow. So normally we like to show how this can highlight things, but we're also going to show how it can fix and pass and be allowed to go on. So this is a screen capture of sort of what we'll see in the IDE and also in the reports that we'll use to drive the remediation. The next slide. We also have Nexus baked in, and while we're not showing off Firewall, Stefania just did that for us and showed some of that. It is here because it's a universal binary repository. It has support for Docker and therefore can start to support your OpenShift environments. It has this built-in intelligence and staging, as Stefania showed off, which is going to be, I'm hearing from ops folks, they're excited for staging to know that there's a barrier between Docker Hub and containers getting into prod. So we're not going to really get into those features in this, but these are the products in here. Also know that this demo is out on GitHub, this environment, and this is really the first pass. We intend to continue to extend it to make it look more like a real world pipeline and add some additional security features and leverage things like staging. But right now, this is where we're at, sort of the initial pass on this. So that's it for the products. Now, where are we at, Siamak? Do we have to, oh no, we're gonna look at the pipeline definition? Right.
Thanks, Curtis, for that. So for what we're gonna show you as a demo is a pipeline with moderate complexity. We have taken the example application from Spring Boot, the pet-kill-link, and we're going to put it in the scenario that we want to build it, test it, look at how we manage the life cycle of this application throughout different stages that it goes through. And along that process, we want to also make sure that we're not pushing anything bad security-wise into these environments. So we're going to use Nexus IQ to scan it at different stages and see, make sure that we fulfill those criteria that we have around security for our application. All the infrastructure I'm going to show you is running on OpenShift, including the application itself. We have two environments for the application. One is the development environment, when we freely deploy stuff, maybe even they have security issues, but since the dev environment, we don't mind much. And then we have the staging environment, which is our pre-production. So we want it to be as strict as our production. And there we want to make sure that it follows all the tests should be green, it shouldn't have any high risk security vulnerability, for example, and we have a strict policy of what kind of releases we can push into our staging environment. And with that, I'm going to jump into the demo and show you how this looks like in action. Here I have my OpenShift environment. Like I said, this is enterprise Kubernetes with a developer-focused web console on top of that. On the left side, we have the service catalog. It's some of the applications that are available to deploy, or images directly on the Kubernetes. You can also, of course, deploy any image from Docker Hub or any other registry, or like Nexus, or like Curtis was introducing, a registry that is hosted on Nexus. You can just specify it here and deploy directly on the platform. We have three projects that we are using here. PetClinic Dev and Stage are our development environment, staging environment. One way to model different environments in OpenShift is through projects. Some users, some teams have different clusters for their different environments. A lot of teams we see, they manage that through project, because one of the things that OpenShift adds on top of Kubernetes is role-based access control. So we can control exactly who can have access to the stage, who can read stuff from the stage project, who can deploy stuff in the dev project. So we have modeled that through our projects. If I go to the staging environment, for example, we already have the PetClinic deployed. Like I said, it's a stock application from Spring, available on GitHub. If we try it out, it's deployed as a container running on this Kubernetes, and it's a web application, quite simple for a PetClinic based on Spring Boot. We have the same application in our development environment as well. And when we are happy with our development phase, then we usually promote stuff to the stage when all tests are green and we have verified that nothing bad is in the code, security-wise, or patterns, bad smells, and so on. And there was a third project that I want to show you, CI/CD. That's where we have all the components of our demo, or infrastructure for CI/CD, that are deployed there. We have a Git server in that environment, which is the source code for our application. We're using GOGS here. It looks like very much like GitHub. It is a standard Git repo, nothing really that exciting about that. Then we have a Jenkins instance, of course, that will be the backbone of our pipeline. We have a Nexus repository when we publish our artifacts, when we build them throughout the process. If you want to manage the lifecycle, come up in a second. While it's loading, we also have Nexus IQ, Nexus Lifecycle, for scanning and making sure that our login, in the meantime, the code that you're pushing in different environment is clean and doesn't have any bad thing in it. And there we have the repository. All right. And the last component, of course, is Sonatype. We use that for some static analysis around the code. So this is the entire environment that we have set up. Like I said, everything is running in OpenShift, all these components, but some of them you might choose in your development production environment to be running outside. Like Nexus is very popular that people deploy it on virtual machine outside OpenShift environment. Git server might be some of that. Some organizations have a Jenkins that is running outside. So in this scenario, you have built the pipeline as a standard Jenkins file. So if I click on that, you can see in the configuration there is a standard pipeline syntax for building Jenkins pipelines, and OpenShift has some plugins added to Jenkins instance that automatically syncs this pipeline with whatever pipeline is defined in Jenkins. You don't have to do it this way. We have just for simplicity put it this way. The more recommended way is that you put your Jenkins file in the Git repo, and that's the model that we usually recommend for using with OpenShift as well. So this would translate to a Jenkins file that would be in the Git repo, and OpenShift will just read that and create a pipeline based on that. Let's start this pipeline and see how it goes. As soon as it starts a pipeline, it creates an instance of that. We are using Jenkins on OpenShift, and with that, the Jenkins on OpenShift does on-demand scaling of the slave images. So as soon as a build runs, it instantiates a new Jenkins slave container for running this build. It helps us scan, it helps us scale, and then after running the build, it scales it down. So we can run many builds at the same time. They wouldn't overload the master Jenkins instance in this case. We can take a look at the logs or the flow of the pipeline running directly in Jenkins as well. Well, I like the Blue Ocean interface a little better, so let's go there. So the pipeline itself is running on Jenkins like any other pipeline, standard Jenkins file. What OpenShift does is that it helps us synchronize these two together and have the same view of the pipeline running in the project close to the other components as well. The first step of our pipeline is building the application. This is where we take the source code from the Git repo that is running in the CI/CD project, run a Maven build on that, make sure that it compiles. Then we run a set of tests on it, the unit tests that are created. And if nothing fails, then we immediately push that release into that version of the artifact into the Nexus repo. While this is happening, we can take a look also in the Nexus repo, the repository that we have. Let's just see if it got to the point yet. From the previous releases, we can look, see that the Pitkill link example is already pushed to Nexus repo. We have many snapshots through the builds we have been running. Now a new version of that going to be pushed since the test has been successful, and immediately after that we start a code analysis. We want to make sure that there are no bad patterns or bugs that can be discovered through analysis in the code. And also we do a we do a Nexus IQ scan to check the status of the code and libraries that we are using against the security policies that are available in Nexus. But at this stage, since we are just building for the development environment, if there are any issues with the code, we don't fail it yet. We just flag it for the developers to be able to take a look at the report and go fix all the issues. Like I said, development environment, we have a more flexible policy around what kind of releases can go into that environment. And as soon as we are happy with that, then we're going to start building a container image. And one of the things that OpenShift does, as you can see, the pipeline is a little orange because of the warnings that we are probably getting around for the code. There might be some security issues. We got to look at that. The build image phase uses OpenShift's capabilities for building container images. If I go to the dev project, see there is a build object. It's one of the capabilities that is added to Kubernetes through OpenShift that allows teams to build container images directly from the source code of the application. So instead of you going around and building Docker files that you don't have control exactly what are the best practices, or you might not be like experts on how what are the security practices around building Docker file, you can just point to your source code and the platform will build a container image for you. A deployment has taken place in the development environment as well. You see that it's immediately doing a rolling update to the new version. However, we can see that the pipeline has failed at the IQ scan stage. We are doing a second scanning before promoting it to this stage. And the reason for that is that at this stage, we want to make sure that there are no security issues with the code or application that we want to push. There is no point of forgiveness at this point, because anything that goes to this stage, if the tests are successful, we will put that in production. And we want to make sure that nothing goes through our hands, and we address the security issues before they get to production. All right, so our pipeline has a little issue, our code has some issues. We have some problem in the scanning. Let's take a look at Nexus IQ and see what are the problems around our code. Okay, I can see that at the build stage, we have found 3 high risk issues and 10 warnings are created. I'm going to hand it over to Curtis now to walk us through what are these issues and what can we do about that to address the issues that are in the code and hopefully rectify them and make a release to the staging environment.
Yeah, excellent. So Derek, if you can pass the screen to me. Whoa, why is it?
You got it.
Okay, there we go. I think we have successfully passed the screen.
It worked.
Hopefully folks can see that now. I can, let's make this just a little bigger, make sure folks can see it. All right, so as Siamak pointed out, our pipeline's broke because we have these 3 issues. So we can start to look in, and now I'm a developer. I can use this information to get the feedback and drive this through remediation. Now, there's some good news here in that the very first thing I look at is the Spring framework itself that this project is showcasing has some issues here as indicated by this red triangle. And without even getting too deep, I can quickly see that there's some new versions available. So that's good news for me. I don't have to spend a lot of time digging into this. I can just go get those new versions and these problems are going to go away. If I wanted to go understand more details about what's going on here, that's all available to us in really easy to understand for developers at the class and almost code level what's happening, along with sharing all of our research in terms of how we came to these conclusions, right? So I think what we'll find is both the Spring expression and Spring core are pretty similar. Jackson data bind, however, is not. Jackson data bind, when we first look at, looks a little disconcerting because there is no good version. There's one more version available to us. It still has our problem. So we're gonna have to drill in here and take a look. Now, fortunately, this is a really interesting one between our security team and theirs. There's been a lot of back and forth about whether or not this has been fixed. The project team has since sort of come to the same conclusion we have, that their whitelist approach is not sufficient, so it's still marked vulnerable. However, if you look at our recommendation, there is a possible workaround here. So if we just don't use the default typing and instead implement our own, right? So it gives our developers the information they need on how they can override this and avoid this problem. So for here, I'm not going to get into the coding of that. But what I am going to show off here is the workflow of how, if we had done that, what we would do. And I would just go to the issue itself, and I'm going to go ahead and update that this is not applicable to us. And I'm going to add that, we've made the coding changes, right? And so once I update this issue has now been marked just in this app as having been remediated at the local level. So that sort of deals with that one, and we'll come back and with the next build, that one should just go away as a byproduct of that. But we've still got to deal with these other 2 that I need some newer versions. So I see now I'm in the IDE, right? I got my palm up. I see them. And so really what I want to do is I want to just, go to the new version and migrate. This would be the happy path here. But what I'm going to get here is a message telling me that it's actually not even declared in this project. We're getting this from the parent POM. So, okay, fair enough. Parent POM it is. So I did a little research out on I did some searching through Maven Central, and I realized that we now have available to us 202 is available to us as the most recent release of this framework, and it's that 3rd digit. So somebody's aware of some of the issues they had and are cleaning them up, as is indicated here. And there may have been other non-security related issues fixed as well. So I'm going to just hit save, and I'm going to rebuild that here locally, right? I just rebuild it all. And if the demo gods are with us, data bind's still sticking around because it hasn't run through the scan to pick up the fact from the server that it's been marked as not applicable. Let me see if I can sort of force that. I just reevaluate here. Yeah, it went away there. And this is, let me just re-hit this one more time. No, still going to hang in there for me, isn't it? But the other Spring ones have gone away, right? Because when we upgraded this, it upgraded them to that newer version that's available to us. So I'm pretty happy with my code for now, and I'm going to go ahead and commit it. So I'm going to come back here. I've got a new we'll update this, right? Commit that off, and I'll push it up. So having done that, that should have kicked off our build. So let's see if I can go see that. I can. So now we've started this pipeline again. Like Siamak, I'm a fan of Blue Ocean visually. If I can jump over there. And if everybody cooperates with us here, this now should be allowed to pass through those this final scan. This should stay green and get promoted to stage, assuming Jackson Databind plays nice with me. And so, you know, what's missing from this at this point, though, and what I alluded to extending this, we want to move that Jenkins file out to the project. That way we'd have branching support. We would be doing this in a branch, and doing the branch would never be able to get past stage no matter what. Once we push the master, it'll be eligible, so we'll start to be able to reflect that. We're also missing one other test here to validate the contents of the container, probably something like OpenSCAP, to validate at the OS and middleware layers, or in this case, it's a Java runtime, that we don't have any issues there. And more importantly, probably than bill of materials, that it's properly configured, right? The right users, right permissions, right folder structures, all those sorts of things. And that would sort of then complete the validation of this container, that it meets all of our requirements to be able to be allowed to go to production from these standpoints. Obviously, we've stubbed out, you know, when we do these deploy to dev and that, there's an implied a bunch of other testing takes place, all the traditional testing that we're already familiar with, that's, you know, sort of outside of the scope of this demo. So that's where we're at now, and let's just keep our fingers crossed here for a minute and see if we'll know when we get this one if it doesn't go yellow, if it doesn't mark it as unsecure. And I think timing wise, we're going to come in right on the clock. So while this is going, policy, we can start to see the output of this. Taking a while to get started. So that's all the SonarQube stuff. Looks like this one's probably waiting for the agent to spin up or something. Is it not going? Oh, it's still flagged it. Jackson Databind did not cooperate. Let me look at that again, see if that's what it was. Oh, I can't go back while it's building. I have to wait till it's done, and I can get back and look at that log. So there you go, live theater, exactly what we were afraid of. Let me just make sure. Or is there? Yeah, it's still Jackson Databind. And this, maybe the issue moved between the version, or it looks like my not applicable didn't take. All right, that cleared it out here. Let's see if we did it in time to get through the, no, it failed in stage. I didn't get there fast enough. So it looks like my waiver of not really waiver, but my audit trail that we had fixed it in code didn't get in there in time, so we still failed. But had that been there, we would have passed this phase. We would have been promoted into stage, allowed to finish our testing. This then would go through a workflow of a pull request off to master, and then we'll get this thing to prod. So hopefully that gives an idea of, now the big takeaways from this though is we have IQ Server running in OpenShift. So even though there's not a certified container out there, we now have templates available to us in this project. So for folks that want to run IQ Server in OpenShift, there's now at least a reference implementation there that people can make their own templates from. So that's something we've been getting asked a lot for. And going forward, Siamak and I will continue to evolve this to start to look more like a complete solution.
Hey, Curtis, this is Derek. Just because we're going to break after this, if you want to run through it again, run through that build, if it's only going to take a couple of minutes, we can. We're not butting up against another speaker, so if you want to restart it, you can certainly go ahead.
Yeah, let me. How do I get it? If I want to kick the build,
I can start it immediately.
Okay, there you go. Yeah,
the Blue Ocean interface is super cool, by the way.
I do like it a lot. This always makes everything look linear, and at least here I can see the parallelization, and we don't use enough of it in this project yet, but as we evolve it, we'll be able to show off. We'll have another parallel step here doing the open SCAP, maybe stub out some of the kinds of testing that can happen here. We'll show it bypass from the pull. So it is a pretty slick UI.
And you can never blame too much security, right? So our policies are very strict here. Unless we're really sure that the issue is fixed with Jackson, we're not going to allow going into staging environment yet.
And I'm glad you mentioned that, just to show the policies. This is actually pretty typical of an early adopter. We would initially set up these policies where everything is set to no action. That's what we call our audit mode. This allows teams to just start to socialize results without impacting developers' workflows, but start getting the feedback, right? Start seeing the kinds of data that's available to them, maybe even give them a chance to clean up before we turn on enforcement. And then a lot of teams like to incrementally add enforcement, right? So they might start out with exactly what I've done, just the high security things. So let's just start with the things that scare us the most, turn those on, make sure everybody's clean, and then we can incrementally add more, start to turn on more policies. And here you see the effect of the warn at build time. We're not going to break the build. That's too soon in the life cycle. We want to know all the problems that we have. We want to run it through all of our testing so we know that. But we don't want to pass this downstream. So sort of depending on how you're set up, you could fail here at stage or release. That's up to you and your life cycle. So just a sense of how the policies are set. Now, this is the complete set at the org. Pet Clinic itself inherits a subset because it doesn't have any categories assigned to it. So it's only inheriting policies that apply to all applications and not ones targeted for specific apps. So if we go back, look at that, we're sort of in it. And we should have a good sense here if it's going to go or not, because this should not go yellow on us.
But I think this shows the point quite clearly of a path to bring security more into that continuous flow of building the code instead of keeping it as a last step, that after everything is released, we get the security team involved. But through products like Nexus IQ, SonarCube, and similar, we can bring those teams to define these policies a lot earlier in that flow, pretty much after every change that is applied to the code.
Yeah, this is consistent with, we need to build this stuff in. It just needs to be part of the process. Our policies allow the security folks to be engaged and collaborating indirectly through these rules. But it also lets people sleep at night knowing that it's always happening, and it's darn near impossible for something to get through here without tripping up a test. So yeah, we're still green, so we're good. Data bind has been successfully fixed this time. And so we see it's off to stage, and now you put in a pause here. It doesn't automatically go to stage. We might wait for an approval or a manual promotion at this point, right? So if we And actually, does this? Oh yeah, here's our. Does this let me do it here, or can you only do it in the other UI? Oh, there it is. So we would have the option here to go ahead and promote this. Go ahead and let our updated build go ahead and deploy to that stage environment where we might do some additional testing and last shakeout before it goes to prod. Awesome. So we got through it. We got a green build, and just in time for the rest of the day.
Awesome. Hey, you guys did great. I'm glad we weren't butting up against another speaker, so we could get that through. I think the Siamak said it was nice to have the it was nice to show the policy enforcement actually works, right? So as you're building through, if you're violating policy, it will stop your build later in the pipeline, as you were able to show as the second one was going, how we apply policies to different phases of the life cycle there. So it's kind of nice to see that in action. If you don't resolve appropriately, the policies do. That's automation is hard to avoid, as we say. So if you've automated your policy, it's hard to step past it there. So we got to see that live. So Curtis, Siamak, thank you. Thank you so much for running through that. That was awesome. It's so nice to see a lot of the live demos. We had, many of the presentations yesterday and even some earlier this morning are talking conceptually about Nexus Lifecycle or Nexus Firewall or policy enforcement in these large environments, but to actually see, the product kind of live and the CI/CD pipeline working and how it actually looks when you're in front of it as a user is pretty cool. And how you're able to show some of the staging steps that even Stefania was demoing in the session before this was kind of cool to see that come to light in the pipeline as well. So good job, guys.
Thanks, Derek. Thanks so much, Matt, for collaborating with me on this.
Of course. It was my pleasure.
All right. Thanks, guys. We're going to break, and we will be back at 2 p.m. on this track with Helen Beal at Ranger 4 talking about artifact repositories in a DevSecOps pipeline. So let me go to share screen.
Got it. Okay.
In the other building.
Okay.
Just moved it over.
Is the general track keeping the same link?
If you
I
can go
deleted
ahead
it.
and join,
No, I deleted Brian.
you'll be able to
Yeah,
disconnect
are you
from
talking about
there,
Brian Dawson?
but you can
We're
join
starting a
that
new
live
track.
link. Just make sure your microphone's muted, that your camera's turned off.
Okay.
We're starting
Hang out
2 new
there.
tracks.